Iron has a density of 7.87 grams per cubic centimeter, and the mass of an iron atom is 9.27 times 10 to the negative 26th kilograms. If the atoms are spherical and tightly packed, what is the distance between the centers of the adjacent atoms, and what is the volume of an iron atom? Accidentally kind of read that backwards, but whatever. We'll deal with part A first, and this is a fairly easy problem all around, as you'll soon see. But first things first, let's rewrite the density so that it's written in SI units to correspond with our other measurements here. So the density is given to us as 7.87 grams per cubic centimeter. But let's convert the grams to kilograms and cubic centimeters to cubic meters. So there's obviously 1 kilogram, or 1,000 grams in 1 kilogram, and let's set it up in a way so that the grams cancel out and it turns to kilograms. And as for the centimeters, let's remember obviously that there are 100 centimeters in a meter, and cube the whole thing so that we can get that dimension conversion as well. And the answer we get for our improved measurement of the density, our improved recording, is 7.87 times 10 to the third power of kilograms per cubic meters. That's much better. Now let's find the volume of the iron atom. So if density is equal to mass over volume, and that means that the volume is going to be equal to the mass over density. So let's sub in our values for that. So the mass we're given then is 9.27 times 10 to the negative 26th of kilograms. And the density, as we're given, as we rewrote it, is 7.87 times 10 to the third power of kilograms per cubic meter. So plugging this into our calculator, the volume we get is 1.18 times 10 to the negative 29th power of cubic meters. And that is our answer for part A. As for part B, which asks, what is the distance between the centers of the adjacent atoms? So in other words, if we imagine the atoms as spheres, and we picture two up next to each other, then what is the distance between the two centers of the adjacent atoms? So if their centers are here, right in the middle, then we want to find out this right here, the distance from one center to the other. And you should notice now, what this basically is the radius of one sphere plus the radius of the other sphere. And if they're both the same, it's just going to be the radius of one of the atoms times 2. So how are we going to get this radius? So because we're using a sphere here, and we have other information about the volume of the sphere, then we know that the volume of a sphere is equal to 4 over 3 times pi times the radius cubed. Now we want to solve for the radius, and fortunately, we have the volume now thanks to the previous part of the problem. So if we use some basic algebra to solve for radius in terms of volume, then the formula we can get is that the radius is equal to 3 times the volume divided by 4 times pi, all to the power of 1 over 3. So plugging in our volume value for it that we got in the previous part, the answer that we get for the radius is 1.41 times 10 to the power of negative 10 meters. And this is the radius of one atom. It's the radius of one iron atom. But we want the distance from the center of one atom to the other atom. So we're going to multiply this radius by 2. And so multiplying this value by 2 gives us a distance of 2.82 times 10 to the negative 10th power of meters. And that is our answer for part B.